In this video, we are going to go over how to graph a linear equation by plugging in values for x and getting out values for y. This is the start of one of the most important and fundamental ideas in all of algebra and beyond. It's the idea that if you put values in for x and get out corresponding values for y, that those values, those x and y pairs, can be graphed to show you what this function looks like visually, not just what it looks like numerically. And I'm going to be repeating this idea big time. So in other words, the points that work in a function are also the very same points that work on the graph for that function. A huge idea that will carry its weight throughout all of your math studies for years to come. Let's do this. It's actually relatively simple. So we're going to start out by picking any old x values that we want. So I'm going to start out with a few negative values and a few positive values. That's a typical way a lot of teachers teach it, and the reason being is you want to have values to the left of this line, so that would be negative x values, as well as positive x values. So let's pick a few negative and a few positive values. So some negative x values, let's do the typical ones that people usually choose are like -2, -1, 0, 1, and 2. Those are the typical ones people choose. You could certainly choose -4 and +4, -5 and 7, whatever you want, but I tend to keep them pretty close to 0. So now all we need to do is plug these numbers into this expression to get out the coordinate pairs, the x, y values that go with -2 and with whatever the y value is. So I plug in -2 and we do what this function tells us to, which is -2 minus 2. -2 minus 2 is -4. So what does that mean? Well, that means that your y value is going to be -4. Perfect. And perhaps in the next line, I'll actually show out the work a little bit better than that. Let's do it in this next one. I'll do -1 minus 2 is equal to -3. So that means the y value is -3 when the x value is -1. So that's the point -1, -3. So I list out all my coordinate pairs and then I'm going to graph them. 0 gets plugged in, so I do 0 minus 2 is -2, nothing magical there, and that's a y value of -2 when x is 0. Beautiful. Now I'm going to plug in +1, so we get 1 minus 2 is equal to -1. That's now the point 1 comma -1. So when x is 1, y is -1. And finally, we plug in the value for 2. That's going to be 2 minus 2 is equal to 0. And that's the point 2 comma 0. And if you wanted to, you could plug in other values. I'll pick one more just for fun. We'll go out to 5. 5 minus 2 is equal to 3. So that's the x value is 5 when the y value is 3. So now what do we do with all of these points here? Well, these are values that are solutions to this equation. And if they're solutions to the equation as numbers, meaning they make the equation true, we can also graph them as coordinates on a graph. Super cool way of seeing what this thing looks like. So I'm going to basically graph -2, -4 as we know how, and as we've seen in previous videos. The x coordinate, to remind you, means go to the left or right however much, and to up or down for the y coordinate however much. So this means go left 2, and then down 4 because of the negative. So from the origin, we go 1, 2, and then down 1, 2, 3, 4. Perfect. And put a point. That's it. Awesome. -1, -3. Left 1, down 3. So left 1, down 1, 2, 3. Beautiful. And then we've got another point, 0, -2. That means don't move left or right, but do move down 2. So starting at the origin, down 1, 2. Awesome. And then from there, move to the right 1 from the origin, and then down 1. So right 1 and then down 1. And you see that this is forming a nice line for linear equation. 2, 0 means move right 2 and then don't go up any. So that would just be over to here, 2, 0. And finally, this means move to the right 5 in the x direction and then up 3. So 1, 2, 3, 4, 5, up 1, 2, 3. And that would still form a line. Now we are going to connect all these points. The reason being is there are x coordinates in between all of these numbers. For instance, there's a point at x equals 1/2 and at x equals 1/3 and at all the x values in between x is 0 and 1. So we should fill in all those points. That's why we connect all the dots with a line, and hopefully I can draw a relatively straight line for y'all. That's not bad. Not bad at all. And we draw arrows to indicate that the line would continue on in that pattern forever and ever. So sweet! That's it, peeps. Plot out the points by doing a little bit of work. Once you have that work, you can plot the points on the graph and then connect them. And you've got your line that represents what this graph looks like. Now, a couple things. One is we're asked to basically answer, is 1, 2 a solution? We can answer this in two ways. We've plugged in the x value of 1 and we got out a y value of -1. So 1, 2 is not a solution because we get out a value of -1 when we plug in 1. The other way of looking at it is look at the graph at 1, 2. That would be over 1 up 2. There's no point on this curve at 1, 2. And since this curve, or line, we call them curves in general, represents all the solutions to this, and 1, 2 is not on it, then we know that 1, 2 is not a solution. Isn't that sweet? I think it's pretty rad. On the other side of this video, I'm going to do one more example for you in case you'd like to see something with maybe a coefficient. What is that, you say? A number, aside from just the invisible 1 next to that x. So we'll rock that. One other thing to note before I close out this clip is the pattern here. The pattern is that for every 1x I plug in, we went up 1y. I plugged in -1 from -2. We went up 1. I plugged in another 1 more from -1 to 0. We went up 1 in the y direction. And you see that here. For every 1 in the x direction, we went up 1. Over 1, up 1. Over 1, up 1. I wonder what that's all about. We'll see that in a later video. To the other side of this video we go. And here we are on the other side of the video. As promised with the second example, we are going to graph y equals -3x plus 5 and then answer the question, is 1, 2 a solution? In other words, when x is 1, does y equal 2? So let's do it. Let's dive into this work. So first things first, as we did in the previous example, we're going to pick some x values. I'm going to stick with -2, -1, 0, 1, and 2 to get a good idea on the left side of the y-axis and the right side of the y-axis of what's happening with this graph. So we'll do -2, -1, 0, 1, and 2. We're going to plug in these values. So I do -3 times -2 plus 5. And I simplify that out. -3 times -2 is 6 plus 5 is 11. So that's the point -2, 11. Now in the previous example, I graphed all the points all at the end. Might as well do it all at once now. -2, 11 means move left 2. And then up 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's going to be like off the board here. 11. So it's going to be a point like way up there. Some might even be off your screen. No worries. We're going to have plenty of other points. Now I'm going to plug in -1. -3, -1. Plug in for x. -3 times -1 is 3 plus 5 is 8. So now I'm going to plug in -1 for x. I got out 8 for y. So that means move left 1, up 8. Left 1, up 1, 2, 3, 4, 5, 6, 7, 8. Beautiful. And I'll put that so you can see it nice and big. All right, next point. We're going to plug in 0. -3 times 0 plus 5. That's an easy one because -3 times 0 is 0. Plus 5 is 5. And then what we have left right there is you've got the point 0, what we plugged in, 5, what we got out. So we'll go neither left nor right because x is 0, and then we'll go up 5. 1, 2, 3, 4, 5. Beautiful. And I'll make that nice and big for you to see. Okay, we plug in 1. -3 times 1 plus 5. -3 times 1 is -3, plus 5 is 2. You get the point 1, 2. Beautiful. We'll move to the right 1 and then up 2. So from the origin, we go right 1 and then up 1, 2. Getting another line. We expected that. It's a linear equation. I'm going to plug in 2. -3 times 2 plus 5. -3 times 2 is -6, plus 5 is -1. So we input 2, we got an output of -1. That means visually we move to the right 2 and then down 1 from the origin. To the right 1, 2, down 1. And you can keep plugging in other values, you're going to get this pattern. Now the import of having that point just barely off the graph right there is this graph continues on off the board, off the screen, and out into the stratosphere and beyond. Right? So there are plenty of points that aren't going to be shown on this graph, but they continue on forever and ever. Even if we have the 4 points, that is enough. Remember, you need to connect those dots, those points, because there are x values in between and beyond all of these that have y coordinates that follow this pattern. The pattern is expressed visually by showing that line. So I'm going to just kind of sketch in a line like this. So like so. Beautiful. That's it. And then of course, as a rough sketch, put an arrow. An arrow on either end says continue in that pattern. And notice that we are moving down 1, 2, 3 in the y direction, and then over 1 in the x direction each time. I wonder if that has anything to do with that number. More to come on that one. Okay, we're going to check to see if 1, 2 is a solution. Well, if you look at the graph, the point 1, 2 over 1 up 2 is on the graph. So yes, it is a solution. Another way of looking at it is if we plug in 1 into the function, we got out a y value of 2. So that's the numerical way of saying it is a solution. Remember, if a point works on the graph, then it works in the equation that that graph represents, and vice versa. If the point works in the function, right, in this expression right here, it's true, then it will also be on the graph of that function. A huge idea in math, but I think a simple one that you can get behind. That's it, peeps. A longer video, I know, but an important one, and I hope it really helped you to rock how to graph linear equations by plugging in values.